All right, welcome back, geometry students. This is going to be lesson 1.2. So now that we have this basic information that we talked about with points, lines, and planes, how do we use that in some more specific geometry terms and vocab that we use throughout the year? So that's what we're going to be talking about today. Hopefully the last video that you guys watched went well, and hopefully you like this setup that we're doing. If not, let me know ways that I can improve or make things a little bit more clear for you as we are using these video notes and online learning and things like that. Okay, so for today, the title is going to be 1.2 segments, bisectors, and midpoint. This should go in your notes directly after 1.1. So we kind of talked about this a little bit. We're having notebook checks, which means when I flip through your notebook and when you flip through your notebook, you should be able to see all of those right in order so that if I'm working on homework 1.3 later on and I need to go back, okay, I can just flip through right in order and see what we did that day. Okay. Date, as always, is optional. Today's date is either the 14th or the 15th, depending on what day of class. And the objective for today, what we're trying to do is we want to be able to solve for different measurements using what we call the segment addition postulate, and then also using these things called segment bisectors. We'll kind of get into all that. Okay. So first definition we need to write for today is what is a line segment? What does that mean? We talked about lines. Now how are we getting more specific? Okay, so a line segment, and we'll do, let's try to find this color here. Okay, a line segment is just going to be a line that has two endpoints. A line that has two endpoints. So this is very similar to what we talked about on last video, right? A line, but in this case it doesn't extend out infinitely in all directions. Okay, and the reason this is helpful and the reason we talk about this a lot is because if it has two endpoints, then it can be measured. And I'll write this on the next line actually. It can be measured. Okay, so for an example of that, what those will look like, and we'll see a lot of line segments obviously as we go through geometry and talking about shapes and different things like that. If I just draw this line here that we talked about last week, if I just put 2 points on that line, doesn't matter, again we use capital letters, right, for points, so A and B. Okay, what I want, or why we call this a line segment, is because it does not go infinitely in both directions. Because if I asked you to measure this line right now, you couldn't tell me because, like we just said, it's just going to keep going. Okay, so what I want if I'm looking at a line segment is not the arrows, but those are the endpoints. That's where that line stops. And so this would be line segment AB. And then I can actually measure this as well. Okay, and then how we name it, last time we talked about naming it by just 2 points on the line. In this case, we're always going to name it by its two endpoints. So in this case, we'd say this is line segment AB. And then we talked about this a little bit. We want to use that same symbol when we're going through our naming. So I can just put a little line segment here. I'm not going to put arrows going out in either direction because it does stop, but this would be line segment AB. So again, that's what I want to get in the habit of naming some of these lines here. Okay, so that's a line segment. And then another thing that we're going to use to solve some of the problems for today is what we call the segment addition postulate. Okay. So the segment addition postulate says this. It kind of uses technical geometry terms. It says if there is a point M, okay, so if there is a point, wow, that was brutal. If there is a point M between, and M is just any letter, it could be any letter in the alphabet. If there's a point M between endpoints P and Q on a line segment, if there's a point P in between two endpoints P and Q on a line segment, then, and we'll draw in a diagram of this here in a sec as well, then what we can say from the segment addition postulate is we're adding segments, right? So I would say segment PM, I'm going to put that little line above it, plus segment MQ. And when I say segment PM, I mean the length of, or the measurement of PM plus MQ equals the line segment, the whole thing, PQ. Okay, so like I said, that's the technical geometry definition. If we want to see what this actually looks like, it's fairly straightforward. So I just need to create this picture that it kind of drew out in the definition. So we have a line segment here, P and Q, and it's saying we can put M somewhere in between them. So it could be far on the left side, far on the right side, it could be dead in the middle. And I put point M here. And so what I would say if I was looking at this, if I were to measure these line segments, PM and MQ, if I took those two segments and I added them together, I should get the whole thing, right? The part plus the part is going to equal the whole thing. And so that's where this comes from. PM plus MQ equals PQ. Okay? And I do have students for some reason struggle with this at the beginning of the year, but it's just that basic concept. If I'm looking at an entire line and I have just that one point, if I take the two parts of that line and add them together, it's always going to give me the distance of, or the length of, the entire thing. Okay? So that is the basic idea. So how do we use that in some problems? Let's look at that a little bit here. Okay, first one, move myself up to the top here. Okay, if I'm looking at example 1, I have this line segment and I have the whole thing, so I name it JL because those are the two endpoints. I have line segment JL and I want to find the length of that. Okay, well, if I want to do that, and I'll give you a sec to pause and draw this diagram for me real quick. So make sure you draw this diagram, make sure you have the specific length, so the 8.4 centimeters and the points, and then once you're done writing that, you can unpause and come back. Okay, so if you have it written down, and make sure that you do have it written down on your notes, if I'm looking at this and I want to find the length of JL, and I'm thinking without using numbers, just using the names of the segments, how would I come up with an equation? Well, it's just like the one we just talked about with the segment addition postulate. So I'm going to take the part plus the part. So I see this is line segment JK here. So just using the names at first, for this first one I would say length of JK plus the length of the other part, KL, is always going to equal the length of the whole thing, which in this case would be length JL. Okay, so if I just wanted to set up an equation, the basic idea or the concept, that's what it would look like. Now all I have to do is just plug in those specific lengths. So it already tells me the length of JK is 8.4 plus the length of KL, which is 3.9. And in this case, I don't have the length of JL. I could put X, I could put length of JL, whatever works for you guys. Okay? And now I just want to do this, and I can either do this in my calculator or do this in my head. If I have length of JL, all I need to do is add 8.4, excuse me, and 3.9, and what I should get is 12.3. Okay, when I add those two things together. Okay, so 12.3 should be my final answer here. Okay, and then what I want to add on this as well, since it is geometry and since we're trying to get in the habit of labeling things, I got to ask myself, is there a unit? Is there feet? Centimeters, millimeters, whatever. And in this case, I do see that we have centimeters. And so that's my final answer, so that's what I'm going to circle. Again, just adding the two parts together. Okay? All right, moving on. Now, can we use that if we combine it with algebra that we learned last year? Would I be able to do that? Okay, so this is still example 1. This is just part B. I'll give you a sec, and I want you to draw this diagram for me. Label all the points, and make sure you label all of the variables and numbers as well. Okay, so once you have that drawn, we have this here. Again, I'm going to do the same thing. I'm just going to get in this habit. You don't have to do this on all the problems, but if you want to visualize what it would look like, if I want to set up an equation, eventually I do want to find the value of A, but to do that I need to set up my equations. So how are we going to set up those equations? Same way as we did before. I'm going to have the part, so length xy, plus the other part, length yz. Again, notice I'm putting this little symbol, that little line above all my letters. I'm not just writing YZ, I'm putting that line above it. And that's always going to equal, part plus the part is always going to equal the whole thing. So in this case, XZ. So line segment XZ. Okay, so we have that here, and we do have all these lengths. Might not necessarily be numbers, might be some variables in there. But now we can write it in terms of numbers and variables. Okay, so XY is 3A. Plus YZ, if I look at that, that's just 14. And then the length of XZ is going to be 5A minus 4. Okay, so I've just plugged all these things in here, substituting them in. And now I just need to solve this like an equation that I did last year in algebra. Okay, so first step, multiple choices here. My recommendation would just be to get variables on one side, numbers on the other. So I have a positive 3a over here. I want to get rid of that. So what do I do with that? I subtract 3a. What I do to one side, I have to do to the other. Okay, when I do that, these cancel. Leave me with 14 equals. If I have 5a minus 3a, okay, remember the numbers in front are what we call the coefficients. You subtract those, and then the a just stays the same. The a is just like a label. Okay, so 5a minus 3a is 2a, and then minus 4. Next step, get the numbers to the other side. I have a negative 4 or a minus 4 on the right side of the equation. I want to get rid of that, so I add 4. When I do that, these cancel. I get 14 plus 4. Hopefully you know that's 18 equals 2a. And then last step here, just divide by that number in front of the variable. Divide by 2, right? So I'm going to bring my answer over here. In this case, I have a equals 18 divided by 2, which is going to be 9. And I can circle that here. Sometimes in our geometry problems, we'll have to plug this back in. In this case, I double check. It said just find the value of a. I found that, so we're good. Okay, and again, if I wanted to, just like any other algebra problem, if I wanted to double check and make sure this is right, what I could do is I could just plug this into my diagram here. So plug in 9 for a, and then see do those lengths actually come out to be the same, and they should if we've done it correctly. Okay, so that's using the segment addition postulate. Okay, a few other things that we need to talk about as well. Okay, something that we'll see a lot in geometry. Next definition here is going to be congruent segments. Congruent segments. Okay, and congruent segments, if you hear that word congruent, okay, that just means two or more segments that have the same length. Okay, two or more segments that have the same length. They're congruent, or in other words, they're equal. They're equal in length. Okay, so if I want an example of this, if I just want to see what this looks like here, we can just create two segments. Okay, line segment CD, and then I'll try to make it as congruent as I can. Line segment EF. Okay, and if I wanted to know that these are congruent, because we're going to see this a lot. We're going to see a lot of diagrams in geometry. And if I want to see if these are congruent, I can look for two things. Either number one, I could just try to measure these and see, okay, are these the exact same length? And that can get a little finicky. So what we do instead is anytime we see two segments that are congruent, or a diagram is made for you, all we do is we have a dash mark on the segments that are congruent. So these little marks right here, this just little dash, sometimes it'll be a different color, tells me that if I look at these two segments and they are both have a dash mark on it, they are congruent. They are the same length. And we use that a lot to set up different problems and solve different problems. Okay, so understand if you ever see that in a diagram, that means the segments are congruent. Okay. Next thing we need to know, next term is a segment bisector. Okay, and a segment bisector is a point, line, or plane. Okay, a point, line, or plane that basically divides, or I'm going to put in parentheses here, if I can erase this, divides or cuts a segment into two congruent halves. Into two congruent halves. Okay, so write that down and then take a sec and try to understand that. A segment bisector is a point, line, or plane that divides, I really like to use the word cuts instead. It cuts a segment into two congruent halves. So when you hear that word bisect just means cut in half. Okay, so I'm just taking one line segment, cutting it right down the middle, cutting it in half. That's what that looks like. Okay, so for example here, okay, let's say we have line segment JK. Okay, and then let's say it intersects with another line. We talked about that word last video, right? Intersects. Let's say we just have intersection point here. And we'll say this is LM, or intersection line, I should say. If I were to look at this and I saw that, and if I was told LM is the segment bisector, what that means is it cuts it into two equal halves, right? Okay. And so or two congruent halves, I should say. So we know when I have congruent, that means I can mark that with 2 dash marks. So now I'm saying J, and then whatever this intersection point is, let's just call it N. Jn is going to be congruent to, Jn is going to be congruent to Nk. Okay, that's what that means. You'll hear that with segments, you'll hear that with bisectors. It just means cut in half. 2 congruent halves come out of it. Okay? And then last definition that we need to learn for today is the midpoint. Okay, midpoint as a technical definition, we'll try to use something similar to what we talked about or just talked about. Okay, the midpoint is kind of what you'd expect it to be. It is a point where, let's say a point if you have points, we'll just pick some, we'll say same one as last time, J and K. Points, okay, if you have points J and K and Jm is congruent to Mk, and we'll, again, just like the last definition, last definitions, we'll draw a diagram with this. Okay, if you have points J and K, and I say that Jm is congruent to Mk, then M is what we call is the midpoint of JK. If I have a point in between my endpoints here, and I look, and on one side it's the same as the other side, then that means that point's in the middle, right? The midpoint. Okay, so if I want an example of this, kind of like we just drew, okay, we have line segment J and K here. Okay, and then M is going to be that dead middle point, the one that's exactly in the middle. And what this tells me is if I told you this was the midpoint, then I could now say, all right, that makes sense. Now I could just say that Jm is congruent to Mk. Okay, that's why it's important. That's why it's significant. That's why we talk about it. It's like the halfway point, right? If I was running across this line and I got exactly halfway or exactly in the middle, that would be M. And then we can use that again to say, now the segment on the left side of M, the segment on the right side of M, those are both the same. Those are both congruent. Okay, so with that, let's look at example 2 here. Okay, I'll give you a sec to sketch this diagram. Same rules apply as always. Okay, we're saying we're given that Q is the segment bisector. In other words, it cuts that segment in half. It's the segment bisector of PR. Okay, and then what I want to do is I want to find the length of QR. Okay, so the way that we do that, first, if I'm looking at a diagram and I'm given this information, Q is the segment bisector of PR, I want to ask myself, okay, what do I know from that? What information did I just gain? Well, I know it cuts it into 2 congruent halves, right? So we mark that here by saying I can put 2 dash marks. PQ is going to be congruent to QR. Okay, and I can write that out on the side as well. PQ is congruent to QR. And this, I'm sorry, I did not mention this earlier, but this is the congruent symbol. So that means that 2 things are the same length, okay? And it has always an equal sign and then a little squiggly line over top of it, okay? It's very similar to saying equal, except the only difference is you're saying distance rather than these 2 numbers are equal, okay? So if you ever see that symbol, make sure you understand that just means congruent, okay? And then if I wanted to set up this equation, now I understand I have PQ, that's just what we've been told, is 9y minus 2, and then we said that's congruent to, or another way to do that, another way to say that we use in algebra more, was equals. So 9y minus 2 equals, or is the same length as QR, which is 14 plus 5y. Okay, this is the biggest piece, is setting these problems up. Once you have all these problems set up, then it's just going back to your algebra skills that you've learned in the past few years. Okay, so I want to solve for y to start. Okay, so what I do is I look at this here. I want to get variables on one side. I see a positive 5y on the right side. So I'm going to cancel that out by subtracting. So I have 4y minus 2 equals 14. Next step here, get numbers on the other side. So add 2 to both sides. When I do that, these cancel. I'm left with 4y equals 16. Bring this up here. And then last step we know is always to divide by the number in front of the variable. So I get y equals 16 divided by 4, which is 4. And I'm going to circle that answer, y equals 4. Okay, but then again, I always need to double check and make sure, is that what the question was asking for? So I look back here and I see it says I want to find the length of QR. So I can't just stop here. I need to ask myself, okay, how do I find the length of QR with this new information? And I'll give you a hint, it's always going to be the same thing. If you're not solving for a variable, plug that variable back in. So we saw QR is 14 plus 5y. So I'm going to say QR, just so I can visualize this and see what it looks like. QR equals 14 plus 5y. Okay, but now we know what y is, so I can just plug that in. So in parentheses, I'm going to do this anytime I plug a number back in, is I'm just going to put it in the parentheses, and I'm going to say that's 4. All right, and now all we got to do is simplify. So we have 14 plus, we know if I have parentheses or two numbers right next to each other, that means multiplication. Okay, so 5 times 4 is just 20. So the length of QR is 14 plus 20, or 34. And that is my final answer. That is what I'm looking for. Okay, so keep that in mind as you're working through these problems. And again, if we're looking at this, you could even say, would it matter if I plugged it in for PQ? In this case, it would not, because they're the same length, right? So you should get 34 when you plug it into the other one as well. Okay, last thing here, getting used to using formulas. This is just a little one. If I want to find the midpoint, or if I want to find the midpoint, if I want to use a formula, if I'm looking on a number line, here's how you would do that. Or here's the formula you're going to need to know. And we'll learn a more advanced one later on. Okay, the midpoint formula is very simple. It is just x1 plus x2 divided by 2. So if I was looking at a number line and I had points at different numbers, and I said, what's the midpoint? You could either spend time and say, okay, I can just count in, this length to find that exact midpoint or find the exact middle. Or you can just plug in one of the numbers, which would be x1, plug in the other number, x2, and then divide it by 2. Or in other words, kind of like just finding the average of it. Okay, but that is the midpoint formula. Okay, anytime we have a formula in this class, I would recommend you put a box around it, circle around it, underline it, whatever. Make sure it stands out in your notes, because we always want to go back to those. Okay, last one here. To save you guys time, I won't make you draw this diagram, but I want to use the midpoint formula and see what that looks like to find the midpoint of AC. Okay, and you're going to see this on some diagrams in geometry. Sometimes you're going to be given more information than you need, and you need to figure out what's really important, and then what can I just get rid of. Okay, so it says I want to find the midpoint of line segment AC. Oh, kick me out for a sec. Scroll back down. So what I'm going to do is I'm going to put my point at A, put my point at C, and draw that line segment. Okay, and then it doesn't mention anything about B or D, so what I'm going to do is I'm just going to cross those out. Okay, because I don't need to worry about those. I just need to focus on what's going on right here. Okay, if I want to find the midpoint of that, again, I use that equation, x1 plus x2 divided by 2. Okay, or in other words, x1 is just one of the points. So I know one of the points, A, is at negative 12. So I'm going to plug that in. I'm going to say negative 12 plus x2, which we see that point is C, and that is at 6. I'm going to put plus 6, and then all divided by 2. Okay, again, if you wanted to, you could actually put your fingers on the edges of these and just try to count in one at a time. But in my opinion, it's easier just to use a formula and just find the average of it. Okay. So if I'm looking at this here, now all I need to do is simplify this. So I have negative 12 plus 6. So make sure you understand how to add and subtract negative and positive numbers. Okay, negative 12 plus a positive 6, that's going to bring it more positive, but that's going to bring me to negative 6. And then divide it by 2. And then last step here, put this over here, negative 6 divided by 2. Well, I know 6 divided by 2 is 3, and then negative divided by a positive is a negative. So this is going to be negative 3. And that would be my final answer. That is the midpoint of AC here. Okay, so there might be a problem like that on your exit ticket. Just make sure you keep that in mind. Get in the habit of using that formula. Might seem really easy right now, but we use a lot of formulas in this class, so you want to get used to being able to plug things in for x1, x2, so on and so forth. Okay, rest of time today, or I'll kind of tell you this over the Zoom call, to end today, you are going to be doing the exit ticket for this assignment, or for this lesson 1.2. Okay, so just make sure to check back in with me in the Zoom call. There should be an assignment on class website, and I'll let you know how to work on that and how to submit that. But 1.2 exit ticket is the assignment for today. All right, and that should be it. Thanks, guys.